Good afternoon, students. So now we are going to see the experiment regarding frequency measurement using Wien bridge. So here this Wien bridge is one of the AC bridge. So with the help of this you can measure frequency and also capacitance. So generally here in this experiment we are going to measure the audio range of frequencies, that is 20 Hz to 20 kilohertz. Okay, so with the help of this Wien bridge we are going to measure the frequency in the range of 20 Hz to 20 kilohertz. Okay, so for that we are using this setup. So this kit is NVAS 6506 kit. So it is having some specifications. So for that okay, so these are the specifications of this NVIS 6506. Here the DC power supply range is plus or minus 12 volts and the potentiometer range it is 470 kilo ohms. And next this frequency measurement, for that we are giving some supply, that is sine wave generator with the frequency range of 1 kHz to 5 kHz. So next peak to peak some amplitude is 0 to 2 volts and the potentiometer knob is 1 kilo ohm. So these are the specifications of this NVIS 6506 kit. So coming to the setup, so here this kit is having some internally generated input, that is a sine wave generator which is internally generated, whose amplitude here you can control with the help of this knob, and also whose frequency you can control with the help of this knob. And terminals of this input, here it is indicated as F out and ground. So these are the outputs of this sine wave generator. Now from these terminals we are going to apply input to the bridge. Okay, so the bridge input terminals are represented by plus and minus, and then here you have some null detector terminals 5 and 6. So at this these two terminals we are going to identify the deflection or output. Okay, and this null detector output we are going to apply to the differential amplifier input side, Vx and Vy. So this differential amplifier will give the analog output which is proportional to the difference of these two inputs. Okay, and then the analog output of differential amplifier will be given to this AC to DC converter, because here we are going to display the reading in 7 segment display which is operates for DC only. So that's why we are using AC to DC converter, and then this output of this AC to DC converter will be connected to plus and minus terminals of 7 segment display, and internally it is having analog to digital converter, so it will convert into digital and then it will operate. Okay, so this is about Wien bridge setup. Okay, so now the kit will be switched on, so it will show like this 7 segment display, some garbage value. Okay, so now we are going to apply the input from this sine wave generator to the bridge. So for that, first of all you need to set 1 volt peak to peak amplitude and some frequency, like for example 1 kilohertz. Okay, so for that before going to give connections, so now I am going to connect CRO to this sine wave generator output for checking 1 volt peak to peak and 1 kilohertz frequency. For that you need to go for CRO for observing the waveform. So in this CRO, after giving the connections, click on this auto set button. Here we have an auto set button, it will automatically adjust it to that waveform. So now I am clicking that. Okay, now we can adjust this waveform to the x-axis. So then you can observe that peak to peak value. Otherwise here you have one button is there, that is measure. If you click on this measure button on the channel 1, because the probe is connected to channel 1, so here you can set the required measurements, and after that here I want frequency measurement and peak to peak value, so that's why those two are selected. So now it will display those frequency, that is 471 Hz, and the peak to peak voltage is 1.12 volts. Now I need to set this peak to peak value as 1 and frequency as 1 kHz. Okay, so for that you need to adjust. So you need to adjust these knobs till getting 1 volt peak to peak and frequency 1 kilohertz. Yes, okay, so by varying that knobs, the amplitude and frequency knobs, you can adjust the frequency as 1 kilohertz and the peak to peak value as 1 volt. So after making the connections of the circuit, first of all we will set the variable resistance to VR2 as 160 ohms, and then we have already this frequency is set for 1 kilohertz at the input. Now after that we will calculate this VR1 under balanced condition. Once you got this VR1, then you can calculate this frequency with the help of this formula, which is obtained from bridge balance equations of Wien bridge. And here you have selected capacitances C1, C2 as 1 microfarad, and VR2 is your set value, and the VR1 you are going to measure under balanced condition. So now we are going to measure the variable resistance to this one. You need to set at 160 ohms. Okay, so this 160 ohms we are going to set with the help of this digital multimeter by varying that knob. And here you need to select in multimeter, you need to select the ohm. Ohm means resistance mode. So under this one you can change the range of resistance. So it is in the range of 1 kilo ohm. Now you need to set 160 ohms, that means 0.160.
Ohms or
0.16 kilo ohms means 160. Okay, so 0.16 kilo ohms means that is 160 ohms. Okay, so with the help of multimeter we are setting that VR2 as 160 ohms. Okay, so here we have set this VR2 as 160 ohms, and input also is set for 1 volt and 1 kilohertz, and this VR1 you need to change it from 0 ohms. So that's why first of all you need to keep this knob at extreme left position in anti-clockwise direction. Okay, now you can go for connections. From the input, apply it to the bridge positive, and next ground is connected to negative. So these are the inputs of the Wien bridge, and then after that the bridge output, that is 5 and 6 null detectors. Okay, so this 5 will be connected to Vy and 6 is connected to Vx. So this null detector output will be given to the differential amplifier, which will give the analog output that will be given to AC to DC converter. Then this output of DC converter will be given to 7 segment display. Okay, so initially this 7 segment display is showing it is 924, that is it is showing some value, that means the bridge is under unbalanced condition. Now by changing the VR1 potentiometer, okay, you can observe the 7 segment display reading. So when you are increasing this VR1 resistance, the circuit is going to be balanced. So try to change this spot until you got 0 reading in the display. Okay, so now it is 0, means under balanced condition. It is nothing but, so here balanced is nothing but the potential at the 5th terminal and the potential at the 6th terminal will be same, that is the potential difference between 5 and 6 is 0. Okay, which represents null condition or balanced condition. Okay, so once the bridge is balanced, now remove all the connections.
Bus.
And now check the VR1 value. the resistance of VR1 using multimeter. So here it is showing some 108 ohms of resistance it is showing. So that means for this resistance the bridge is balanced. Stop. Okay, so now we'll go for second reading. So now I am applying the frequency of 2 kHz and we are keeping the peak to peak amplitude as 1 volt only. So as I already told, the frequency is set for 2 kHz. That is done by varying this frequency control knob. Okay, if you want to change the amplitude, you can use this. You can rotate this amplitude control in clockwise direction. Okay, now we need to set the variable resistance VR2 value as 80 ohms, which is given in the manual. Okay, now let us check it. The resistance of this VR2 in multimeter, it is 80 ohms. That means we already set for 80 ohms. Okay, otherwise you need to change the potential knob given for VR2. This knob we need to change. Okay, by adjusting this knob we are setting the required resistance. So after setting this resistance value and as well as this frequency value, now once again make the connections. Give the supply to the input of Wien bridge and take this null detector outputs from Wien bridge. Okay, so now as the bridge is already balanced, it is displaying 0. If you change this knob VR1, it is showing some value. That means bridge is going to be unbalanced. Okay, but you need to maintain bridge as balanced. So by changing this VR1 knob, you can adjust to 0. So okay, display showing 0 means the bridge is under balanced condition. Under this condition, now remove the connections. Check the VR1 resistance value. As VR2 is already set for 80 ohms, now check VR1 resistance in the multimeter. So it is showing 0.073 kilo ohms, means 73 ohms. So for VR2 80 ohms and frequency 2 kHz, we got 70 how much? 73 ohms. Okay, so based on this VR1 and VR2 and the capacitance value already those are fixed in the circuit in the setup 1 microfarad and the input frequency is 2 kHz. Now with the help of this frequency formula calculate the obtained frequency. Okay, so if you calculate that you will get some you will get some 2000. So for these readings you will get some calculated frequency value as 2082.63 Hz. Okay, so once you got this calculated frequency from the circuit, compare this frequency with the input frequency for calculating the error. Okay, so your error is nothing but the measured value minus true value by true value. Okay, with the help of that you can calculate the error. That will be around some 4.6%. Okay, so for this setup you will get generally the error within the range of plus or minus 15%. Okay, so this is the procedure for calculating the frequency using Wien bridge.